wonderful scene in a play by Bertolt Brecht entitled Galileo. And in the scene, the Italian scientist is explaining to a number of his students that Aristotle got it wrong. Aristotle, for instance, explains that metal sinks because it's heavier than water. Galileo doesn't buy that. So he takes a piece of metal and he places it in the water where it floats. Surface tension. Aristotle got it wrong because he didn't test it. He had a hypothesis, but he had no specific evidence. Well, that's the scientific method. You have to have specifics to arrive at the abstract idea. In terms of what we're talking about today, that's induction. For instance, let's pretend I'm a shepherd. Go back about 10,000 years ago, the Neolithic era, and I have a number of sheep. How many do I have? Well, if I want to talk to you about the sheep, I say I've got one for this sheep and one for that sheep and one for that sheep and one for that sheep. What I don't have is a number to represent all of those sheep together, because that's an inductive leap. It's going to take some time before someone says this is 4. 4 is the result of all the individual sticks brought together, and that's induction. This concept of numbers is a metaphor for all inductive thinking. All the disciplines use induction. If I'm working in music, for instance, I have my guitar. I've got 6 individual strings, but they're not organized unless I put them together into a chord. Because a chord is to music what numbers are to math. They're an inductive leap. When I'm thinking inductively, I'm moving from the specific to the general, from the concrete to the abstract. So an inductive leap is an idea, a concept, something large that is made up of particulars or specifics that are organized into a pattern that produces this larger concept. Now, I want to illustrate this by reference to Leonardo da Vinci, probably the quintessential Renaissance man, who compiled a series of notebooks, and the notebooks are filled with particulars, images. He worked on architecture and military exercises as well as painting. Now, Kenneth Clark, historian, commented about the notebooks saying, they tend towards some grand idea of universal knowledge, that's the induction. But at any given point or page, they are focused on the particular and the precise, that's the specifics, observations, experiments, questions, solutions. So when we look at Leonardo's sketchbooks, we see the first part of the inductive process, all those particulars that he's going to work together into a creative whole. Okay, this is the art room, and I'm going to argue again that the inductive process applies to everything, including art. In this case, this is my colleague, Mina.
Hello.
And Mina teaches a variety of classes here in art, including to a 7th grade group. And Mina, as I've been saying for several minutes on this tape, the inductive process applies to art as well, in the way that an artist creates something from scratch with a variety of ideas in smaller parts and then works up to a conclusion. The artist doesn't just create a portrait of someone straight off the bat. It goes through a series of processes, but this is what you teach your kids in 7th grade, correct?
Correct, because one of the most important factors for an artist is to be able to have visual memory. That is what allows them to be able to reproduce something that they see from, visually from reality on paper or even from their mind's eye. And so what we do is we go through a training process in this course where students are basically given different exercises to establish that skill. And even if a student maybe might start out the course with not as great of skills as others, but the training really pays off. I really believe that all students are able to draw accurately
and that's
if
what
they
you
go
do.
through this process.
And you do that by getting them again to, I would say, concretize. They make actual images. You teach them how to develop those images, which they're then going to build up. Okay.
And for example, what I begin with, once they've gone through the initial training process, I give them models or examples to draw from. For example, like the old masters used to teach that way, where you would copy.
Right.
Right?
The sketchbook,
Exactly.
which is what we have
So
here.
in their sketchbook, what they do is they have a bone series that they go through. Well, I give them actual bones to reproduce, to draw, or we go through an anatomy book, and there are pages from the anatomy book that they refer to. So once they get through with all of the bones that are part of the series that they draw, then it culminates with the rib cage drawing. Okay. And so, as you can see, you know, there's all sorts of different skill levels, but the basic, you know, recognition of what it is there, and that gives the student confidence.
Right.
So then, once that is finished, they begin to do the facial features, because
That's what all
you
these
know,
are.
yes.
Again, the small parts that you're going to work up.
Exactly. So they start with a diagram of each feature, and then they do 12 of each feature, right? Once they complete this process, then they do the half portrait, and what that does is kind of, they still receive support by having half of a photograph to draw from. But by this stage, then they're able to reproduce the other half accurately. Once they finish this process, then they go to the full face portrait. And what I teach them is I give them a map so that they can kind of map out the structure of the face, where they start with a midline, and then they measure from the top of the forehead to the bridge of the nose, to the bottom of the nose, top of the lip, and so on. And also measure the distance between the eyes. So then they are able to draw a full face portrait. Now, some kids, depending on their skill level, you know, they might do something, you know, more accurate than another. But basically, they can see the essence of their persona, of their identity inside of that portrait.
Yeah,
So-
and again, you've worked him up from the small parts. I always think of Leonardo da Vinci's sketchbook, and it's a very famous series of images, but the same idea that he was kind of playing with things until he
Right.
arrived at some idea that he could explore in more depth, and you kind of got the kids doing.
Right,
Same
and once
thing.
again, the repetition is very important, because the more that they draw, then the greater their skills will become.
Right.
So, in the sketchbook, you know, I give them weekly assignments where they have to do, let's say, a drawing from an object in their living room, or an object in their bedroom. And then I even teach them a perspective where they create their imaginary ideal bedroom, but they have to draw it from the one-point perspective.
Right.
And so then all of that kind of helps them create a well-balanced experience of what they can do in terms of two-dimensional
And a more
drawing.
developed. I do the same thing when I teach writing. If I have kids write a personal essay about, say, they want to talk about their father, they're going to gather anecdotes, they're going to gather conversations they recall, the details of the room they were sitting in, and they work those all up into a portrait,
Exactly.
in effect, of the dad. That's great.
So if we talk about the inductive method, basically that's rooted in the scientific method, which suggests that the place we're going to get our best example of this is in the science category. So this is Christy Hutton. She teaches science here at Kirby. She teaches biology as well as irascible
life
seventh
science.
graders. Right, seventh grade, okay. And she's got some examples here of phylum and classes. My argument continues to be that science is the epitome of the inductive method, where Carl Linnaeus, going back to the 1700s, finds patterns in nature and starts making taxonomic descriptions. Is that a fair, accurate way to look at it? So this is what phylum?
We're looking at the phylum Arthropoda here. All of these jars are one phylum, and then they've been sectioned off because we've got three classes represented
Okay.
here.
Good. So we've got, this is the ugly spiders over here.
These are the arachnids,
Okay.
and spiders are a member of the arachnid class. And then we've got a crayfish here, which is a member of the crustacean class. And then we've got many members of the insect class, which are grasshopper, butterfly, dragonfly, horsefly, wasp, and a water bug.
Okay, so we'll take this rather repulsive looking guy over here. This is bigger than any grasshopper I've ever seen. When I had them, they were this big and green, and they didn't hurt you. This could hurt me, right?
That won't hurt you.
All right, well, we'll see. All right, so I'm Carl Linnaeus, and I'm trying to make some classification for that. What am I looking for, again, the observational details here?
So Linnaeus would have been looking at the organisms the same way we are, as dead specimens, and he would be looking at the basic body plan that you see from the outside of the organism. So he'd be looking at the way the abdomen's established, so the segmented end of the abdomen is really consistent with this phylum arthropod. The fact that there are 6 appendages, jointed appendages, attached to the thorax makes it a part of the insect class, and this pair of antennae, and then you've got 2 sets of wings on the grasshopper that it fits all the bill for the insect class.
Okay,
So
good.
he would be counting numbers of appendages and segments.
And again, he's looking for patterns here. Now, you were telling me earlier that if we go back to Linnaeus, all our patterning, and this is the epitome of science, is based on observation. So 2 centuries ago, he's observing, as all of us would at that time, simply from the externals.
Right.
But that classification system changes because our ability to observe improves over 2 centuries.
Well, and just the idea of looking at things with different perspective
Okay.
improved. So they started looking at living organisms so they could look at behavioral lifestyles. They started looking at developmental patterns, because with insects you can see some just get bigger, some go through a larval stage and a metamorphosis in a cocoon.
Mhm.
So those things can be used to classify between the different classes. Eventually we got to the point where we could actually look at the genome scale of each of these species, and that's expanding right now greatly.
So our microscopes and our other ways of looking at things have improved.
So yeah, we can actually pull molecules out of these organisms now, and now we're looking for patterns again, but we're looking for patterns in genetic information rather than patterns in the external anatomy, and the genetic information has been conserved since the beginning of time. For 1.5 billion years when bacteria started growing, that genetic information has not changed too drastically, so you can see patterns that have been conserved since well before our ability to begin observing.
Which also makes us able to make inductions about prehistory.
Yes.
Excellent. So there are parts of the country where they cover these in chocolate and eat them,
Yeah.
and I don't understand. Thank you very much.
I want to talk about induction in terms of history. And so I'm here with my friend Don Stoll, who teaches social studies at Kirby. And my argument has always been, and I've shared this with Don, that history is an interpretation. What we read in the books is someone's interpretation of, as Don uses the word particulars, I use the word specifics. So that a historian works with objects, and by kind of examining those objects begins to induce some ideas or abstractions about the culture. Now we've got a variety of things: a courting candle, the pineapple is a symbol of hospitality, and the stereopticon. But I want to bring this to Don's attention. This is a tintype. I'll give that to you to kind of look at, but this is actually my family, some of my ancestors going back to the 1880s. So, and I want you just for a minute here to play historian. If you were looking at for the first time, what kind of particular things would you focus in on?
The fact that both the men are mustachioed and yet otherwise clean shaven, that they're wearing nice clothes, suit jackets,
Almost look like dandies a little
slacks. Yeah, I suppose so. Yeah, the fact that they are somewhat stiff in their bearing.
Very kind of decorum about.
Well,
their
yeah,
sitting.
and that goes along with the absence of a smile, right? I mean, I know that was, of course, based on having seen other tintypes of the era, standard, of course, not to smile. But that goes along with the being nicely dressed, with the very stiff posture.
Even the one man sitting down with the hands in his laps.
Yeah, he does not look comfortable. That's not how I sit. When
No.
I sprawl. I mean, look at this guy. He's sitting like a Marine, right? And so all of that, and how fascinating this background, which appears
Right.
to be a gazebo,
Yeah.
is undoubtedly artificial. I mean, this has got to be a gazebo drawn or painted on a background,
Yeah.
it seems to me.
Which begs the question,
But,
why? Why choose that particular
Yeah,
background?
yeah, and I'm incapable of drawing any conclusions on the basis of one tintype, but these are just some of the things that you would look at, and you would, of course, if you could get your hands on other tintypes of the
Yeah.
era, you'd see if things like that reoccur.
Well, you start to see a pattern.
Of
And I
course,
think,
yeah,
again, that's how the
yeah.
historian, as you say, the particulars, you start gathering a bunch of particulars, and you started noticing some type of a repeated idea or image, and there's your
Absolutely,
reflection. So,
absolutely, yeah.
excellent. All right, 57 in a row. Thank you very much, Joe. When we talk about the inductive process, it isn't relegated just to academics. My good friend Joe here is going to show how we deal with this in sports as well. So Joe is my colleague in English, and he's learned how to play basketball in the inner city, so he knows what he's doing. Now, my argument is that even sports still breaks the movements down into individual steps. That's an inductive process. So when I was 10 and my coach taught me how to do a layup, it was the most uncomfortable thing in the world because I wanted to go off my right foot, which is the wrong foot. Joe's going to demonstrate what happens when you go off the right foot. It doesn't look pretty.
It's not a pretty sight.
All right, so again, this is not the way you're supposed to do it. And you can see how horrible that looks. All right, the idea being that when you want to do a layup, in point of fact, if you're a righty like we are, you go off your left foot. So talk a little about some of the steps that are involved. This isn't just a matter of, hey, head for the basket and throw the ball up. What do you literally have to do step by step?
Well, you have to think about your feet. You have to think about your rhythm. You have to think about actually retraining your natural proclivities to go off your right foot, and then you have to put it all together so you can be fluid in a
And you actually
situation.
spring, you put more effort off of one leg and you kind of counterbalance it.
Yeah, there's a whole lot of coordination
Exactly.
involved.
And this is what it looks like when you finish. So this is a good version we're going to get here. The idea being that the process, there you go, is very awkward at first until you learn how to do it, but once you break those things down into the individual steps, then it becomes a layup. And you learn how to be a good shooter. We're going to edit that out, okay? All right, you got pens, pencils? All right, you know the drill. I'm going to give you about 5 minutes. Go through, mark up, make notes, and then we will discuss as a class. In English, inductive reasoning is the key skill in analyzing texts. When we examine a poem, play, or story, we isolate key words or phrases and then look for the patterns they create to generate the author's theme. When I teach this skill to my students, I invite them to think inductively, which means they first identify words, phrases, or images. These are the specifics, the particulars of the work. They then explain what the words connote or suggest, what ideas they generate. These are the inductions. Finally, we'll review the inductions, looking for patterns that indicate an overarching idea. So we're going to break it down. Again, the emphasis isn't trying to leap to what the meaning is. This is something you're going to have to kind of go through step by step. So what we're going to do is I will ask you what particular words, phrases, or images that you circled. While the students study the passage, in this case the poem Autorec by Carl Shapiro, I make 2 columns on the board, examples and inductions. In the second part of the exercise, I list student examples of both on the board so they can visually see the patterns emerge. So I just want to take your hand, start with the most basic thing. Tell me what you circled.
There's the light, like pulsing out red light in the first part. There's the ruby and the silver again. There's the lanterns hung. There's the clock making notes under the light. So there's a lot of things about light.
Okay, so you're noticing a pattern. Does that have any suggestions for you, any connotations about light?
The poem definitely has quite a bit to do with death, and so I think the light, that is a pretty obvious relation right there between the light and the death.
So keep talking. So light in the context of death suggests what to you?
Well, the idea of an afterlife and the idea of something and more meaning than just dying.
Okay, I'm going to ask you to keep talking because I like what you're saying. What do you mean when you say more meaning?
Well, it gets more into it toward the end of the poem, but yeah, the idea of finding meaning in death and the idea of being rewarded during death, like death being something that, death being more than just an end, but beginning to something, that idea.
Okay, good. Roy.
With death, we do know, or at least we think we know why it happens, and we have rules and regulations governing it, but it's like physics. I mean, physics are the natural laws. They're well be accepted about the world, what we think we know about the world, and let's just say, no, you don't.
Yeah, I mean, counsel, as you say, physics is natural law. Physics explains things. What do you make of the fact that this, and it's not an identified object, cancels our physics with a sneer?
It's really a scary image because
Very.
we rely on logic to understand the world. You know, when he gives this list of death.
Sneer, I want to investigate that. What's the connotation to you of sneer? Would you like someone to sneer at you? Finally, we ask the inductive question. What does this all mean? The students invariably come up with different ideas, which is fine. I'm less interested in right answers than in well-defended ones. The point is to generate an idea from a close examination of the text. All right, so this is the final stage. I wanted to go from our examples through our induction, so let's review. You're now asking the question, so what does this all add up to? This is the inductive leap. We've got a series of isolated observations and facts, but what does it culminate in? So, I'm not going to review these. If you were writing a paper, you would have a plethora of examples to deal with, and you would obviously not use all of your inductions, but from these you would start to draw some central idea. That's the inductive leap. So let's just review. And again, not all these are going to work, not all of them are going to agree with each other, but let's sift and find out what we want to focus on. A number of you pointed out that obviously this is a horrific event, and yet there's so many pretty, beautiful, consoling images in this. Obviously this deals with death, but maybe there's a suggestion of an afterlife of death. The idea that we are trying to, through this kind of incident, and this happens when we face death, we try and find more meaning.
Suggesting that it's not enough. It doesn't explain the world. It just kind of approaches it. It can describe the motion of the car and how it impacts and all that, but it can't tell us why.
Can't quite make it.
What's the connotation of that to you when you say it's dark, the light can't make it?
Well, that, I don't know, kind of in, about the accidents, like, there's all this horror, and it doesn't seem like there's any hope, and, like, hope can't live in this environment.
So if we're talking about things we don't know, death is almost the ultimate thing we don't know. So, as we finish this film, we're here in the final stages. I'm in the editing room with Nigel.
Hi.
Hello. Nigel is helping me put this whole film together, and as you can see, he's working with individual scenes, snippets, which we're going to organize to create this film. So this film itself is an example of inductive action. All these individual parts produce the whole. And that's the idea I want to leave you with. In order to work inductively, whatever discipline you are in, you work from particulars, from specifics, to produce a final result. And that might be a notion, it might be an idea, a concept. Because all ideas are composed of specifics, smaller items that work together to inductively produce a larger whole. And those specifics can be something as simple as a note, a stick, a sketch, an image, or a piece of metal floating in water.